Hello students, welcome to my channel. Today I will discuss you about the periodic tables, the fifth part of the periodic tables. I have also discussed the first, second, third, fourth topic, which who have not seen, who have not learned, go to the description box, link is given there. One information is that you can follow me in my Instagram, and my profile is given in the description box. Okay. So, today the main topic, come to the topic, the first is electron affinity, that is called electron gain enthalpy, then it is the exceptional rules and ionization potential, valency, electronegativity. I will discuss all these things today. First, come to the definition of first electron affinity. What is electron affinity and what is electron gain enthalpy? Let us come guys, start the definition of electron affinity. This is the first term. So, what is electron affinity? Electron affinity is the amount of energy released when an electron is added to an isolated gaseous atom to its last cell. Okay? The last cell में एक इलेक्ट्रॉन we have to enter. उसके लिए एनर्जी हमको उसको रिलीज करना है. It is the amount of energy released when an electron is added to an isolated gaseous atom to its last cell. That is energy change taking place when an isolated gaseous atom accepts an electron to form gaseous anion. So this is the energy released to enter an electron. This is known as the electron affinity by electron gain enthalpy. So, give an example. This is also the exothermic process. Exothermic process. Okay. Suppose an electron this is an atom. It gain an electron. Okay. And it change into gaseous anion. This is gaseous atom. It gains an electron, that is electron is added, and it is gaseous anion, and also release energy released. Clear? This is so delta H, and this will be positive or negative. Negative, the energy will be negative out here positive. Energy released positive, it will be positive. Yeah. Again, example, Fe gain electron, Fe minus. Okay, this is the anion. This is energy released. So out here delta H equals to minus in this case. In this case, delta H equals to minus, most probably 141, not required to remember this value, it will be given just 141 kilojoule per mole inverse joule, kilojoule mole inverse per mole. Okay. The electron affinity, what is electron affinity? Which is in general term Bengali में जो चाहिदा affinity, demand. चाहिदा affinity more, that is negative, and affinity less, that will be positive. Delta H will be positive. Affinity less, delta will be negative, and affinity more, delta will be positive. Clear? Okay. Suppose oxygen, in the thermodynamics, in case of thermodynamics, you also learn. I will tell in your thermodynamics classes in the third, fourth chapters. There is a system, boundaries, all are, that is in which this is the system when I am doing out this work, and without the system other things is the boundaries. In the work in which it is being done, that is the system, and except system, the outside surroundings. In that case, what happens? It will be details discussed in the thermodynamics classes. That is a system. If heat is supplied, heat is gained, then delta H positive. If the system loss heat, release heat, it will be negative. Delta H will be negative. Clear? In the thermodynamics classes, I also discuss in details. Now, if oxygen O2 oxygen gain an electron, it will be O negative. Clear? Yes, O negative. And also some energy will be released. Energy will be released. The energy required, that is, the energy will be negative. In this case, this is suppose O1. This is O1. In this case, again, from this negative, that is the anion, if you want to again add electron, it will be O2 minus. Okay, O2 minus by minus 2, you can this write it double minus. So, in this case, more energy will be required out there. The air delta H will be positive because already is negative there. So, he has not a tendency to gain electron. So, extra electron, if you want to enter the extra electron, I have to give extra energy, and this energy is known as second energy, second ionization energy, enthalpy, first ionization enthalpy, first ionization energy, second ionization energy. In this way, it will be the energy required from first and then second, then third, it will be greater than this. Okay. So, next, the factor, there is the unit and also factor in which unit we can express the affinity by electron gain enthalpy. Electron affinity by electron gain enthalpy, in which unit you have to express. You can express electron volt per mole, kilojoule per mole, okay, kilocalorie per mole, by mole inverse. This is the unit. When energy is released, you must remember, when energy is released, affinity will be positive. When energy is supplied, affinity will be negative. Let us come in which factors the energy or the electron affinity depends. Main factor is that nuclear energy. Nuclear energy. Factor key? Nuclear energy. Nuclear energy. Z. Number 2, atomic size. Atomic size. Okay. Number 3, electronic configuration. Electronic configuration. I am writing in short. Electronic configurations. This is the main factors upon which affinity depends. How it depends? Remember, the nuclear energy, it is the directly proportional. Okay, that is the greater the number of charge, greater the affinity. Charge will be greater, affinity will be greater. And at atomic size, it is inversely proportional. It is inversely proportional. Surge, that means inversely proportional means larger the size and smaller the size. That means larger the size, more the distance of electron from the nucleus, more the distance, and smaller the affinity. Larger the size, smaller the affinity. Smaller the size, greater the affinity. It is the inversely proportional with the atomic size. Clear? And the electronic configuration. Electron configuration means in case of stable electronic configuration, that is an half fill or full fill orbitals, in case of stable atomic orbital, stable. See, in case of noble gases, you can see stable means no electron can be lost, no electron can be gained. So, if extra electron have to be added, I have to give extra energy. Okay? That means stable electron configuration, half fill or full fill, was less affinity, and it will be only positive. Will be positive, energy less, okay, less affinity, the energy will be positive. Now energy हमको देना पड़ेगा. Clear? Now come to the variation of the periodic table of the according to the period and groups. Variation. That means left to right क्या होगा, top to bottom क्या होगा, electron affinity बढ़ेगा, घटेगा, क्या होगा? What is she? Depends upon the factor. That is left right. What is she? Electron is being added. That is mean charge is also added. Charge is increasing. Clear? That means but size of the atom will be key. Decrease or increase? Decrease, because no extra cell is added. Within the same cell, electron is being added. So attraction. What will be the trends? Electron affinity also increase according to the left to right. It will increase or decrease. It will increase because charge is increased, size decreased. I have told the factor how it depends upon the charge and the size. So it will increase, and down the group it is reverse. Always remember, if it is increase, I have told yesterday, it will be decrease. So down the group affinity will be decreased. Clear? That is the in case of halogen, fluorine, chlorine, bromine. This is will be decreased. The highest affinity is fluorine, is the highest. Remember, fluorine has the highest electron affinity. Clear? Next. Very important things, affinity, electron gaining enthalpy, and also some exception. This is the chemistry. Chemistry में exception होगा ही. Without exception, there is no chemistry. This is the only subject which have each and every chapter, it has every discussion there is exception. And exception is the point in which exam depends, in which the cracking depends. All competitive exams, the questions come from the exception. Come to the exception, already discussed on come to the exception, which will come in the competitive exams. So what exception, what is C in the group or in the period, what is C, it is increasing, and according to group wise the value negativity or affinity all is decreased. So what is C out here, according to the oxygen and sulfur, fluorine and chlorine, what is C, oxygen will be greater than sulfur lesser, fluorine greater, sulfur lesser. So what is C, what is you will see out here, it will be reversed. Sulfur will be greater, electron affinity of sulfur will be greater than oxygen, chlorine is greater than fluorine. Why? See out here. What is C? Oxygen electron configuration 8, 1:2:2p4, sulfur 1:2:2p6, 3:3p4. If one electron is added, if we want to add one electrons out here, the electron enter into 2p orbitals, and here electrons will enter in the 3p orbitals. So what we see in case of fluorine also same thing, chlorine also same thing, chlorine 3s2 3p5 also out here, fluorine also same thing 2s2 9 the 2p5. So one electron will be entered in 2p orbitals, here 3p orbitals. So 3p orbitals have bigger in size, bigger space than that of the 2p orbitals. 2p orbital lesser space. So in here electron repulsion is more. So here we are, it is not. So affinity will be here greater. So it is what we obtain, the affinity of oxygen is not so greater, affinity of sulfur is greater than oxygen, and chlorine is greater than fluorine, which is opposite to the rules. Clear? Next, So, it is completed the electron affinity. So, electron affinity and electron enthalpy just nearest same, and it is difference a little bit. The electron affinity always normally positive, electron delta H, that is electron gain enthalpy, delta H Eg always negative, and delta H G electron gain enthalpy will be negative of electron affinity. This is the main thing, nothing else. And electron affinity it gain enthalpy, इलेक्ट्रॉन सब उसको देना है. दिस इज द रिलेशन यू मस्ट नो, एंड यूनिट इज ऑल्सो नो इलेक्ट्रॉन वोल्ट पर एटम, which sometimes I have told electron volt per mole, it will be atom. Okay, kilocalorie per mole, kilojoule per mole. Okay, so next I will discuss about some critical questions which will come in the competitive exam. Okay, come ionization potential. It is the some simple form IP. It is just opposite of the electron affinity. In case of affinity, energy required to enter, and it is the minimum energy required to remove an electron from the isolated gaseous atom, okay, from the last cells. That is the isolated gaseous atom. Here is an electron. So, we have to remove this electron. This electron have to be removed. So, you have to give amount of energy required. The amount of energy required to remove an electron from the isolated gaseous atom, this is known as ionization potential. Okay, clear? So, let us see. IV always says in case of affinity it is negative positive, but in case of IP it is always positive, remember that. Okay. Suppose what is given example, oxygen, this one electron have to be the energy required to remove an electron. If oxygen remove an electron, it will what? That means one electron will be removed, then it will form oxygen plus. Clear? Oxygen plus. That means in case of oxygen you have to give added energy. That energy I mean the first ionization potential energy is give. So, it is positive ion. If again from this positive ion I have to again one electron I have to remove, then it will be double positive ion. Okay. And from this positive ion, this is I2 energy to be given. Again, if I2 give I3 the energy, it will to remove one extra more electron, so on it will be triple positive ions. So, in this case what will happen, whatever the energy required in this first case, it is more greater than this first, that is I2 is greater than I1, and also I3 is also greater than I2, means more energy is required. So, what is the comparison out here? Out here we get I3 is greater than I2 is greater than I1. This is a successive ionization potential. Okay, gradually increase. First, this is known as first ionization potential, this is known as second ionization potential, this is third ionization potential, and so on. Clear? Next, and always remember ionization potential, it is just opposite to the electron affinity. Unit will be same, electron volt per mole inverse, okay, and also kilocalorie per mole, and also kilojoule per mole, okay. And here also some factors requiring the size of the atoms, the size of the anions, the radius, and also the electronic configuration also, and nuclear charge also, shielding effect, penetrating effect, noble gas. All these the factors upon which the IP depends. Okay. So, come discuss. So, what is the size of the ion I told, and nuclear charge. What you see, the charge is from left to right, that is the next, that is the from up to down, from left to right. What will be the trends of the ionization potential? See, the size, if size increase, that is the size of the atom increase. If size of the atom decrease, we know according to period, decrease according to group, it will increase the size. Okay. So, number, the nuclear charge and also electronic configurations and also penetrating effect, all these are very important, but nuclear charge, the nucleus with greater nuclear charge bound the electron firmly, hence large amount of energy required to remove the electron from atom. Clear? And also in case of electronic configuration, in case of half fill and full fill, there will be a variation, and half fill, full fill, or no half fill, no full fill, partially fill, there will be variation. In case of nitrogen and oxygen, what will happen? What you see, the trains from left to right, it is increasing, and top to bottom decreasing, it is decreasing, it is high, increasing, left to right according to the period IP, and according to the group it is decreasing. These are the down arrow. So, what we see out there? Oxygen and nitrogen. That this is increasing, the nitrogen and oxygen. The nitrogen will be lesser than oxygen ionization potential, but here is the exceptional. What? Nitrogen will be greater oxygen, but in some cases what we see after some time, that there is a variation. It will not, how nitrogen is greater than oxygen. See an example, nitrogen 1s2, 2s2, 2p, nitrogen कितना है 7, तो 2p3, oxygen 8, 1s2, 2s2, 2p4, there is p3 electron, in the p subshell there is 3, this is 1, 2, 3, that is 3 half filled in case of nitrogen. In case of oxygen, there is not half filled, 2s2, okay, 1, 2, 3, and this is 4. This is not half filled, this is partially filled. So, this is more stable than this. This is stable, the stable is more, that is more energy to be required to remove the electron. So, IP of nitrogen is greater than IP of oxygen. IP of nitrogen is greater than IP of oxygen. It is slightly change, exceptional case. Okay. So, come out next. Clear हुआ? What you see, left right increase, but here decrease, that is oxygen should be greater than the nitrogen, but out here nitrogen is greater than oxygen. There are so many exceptions. Okay. So, let us I am giving the examples of the exception. In always there, it is the fascination of the chemistry, the exception. अरे exception होता है क्या? Without exception, chemistry is not complete. There is the incomplete study of chemistry if there is no exception. So, in case of this, what you see, according to the period it is increasing, and according to the group IP is decreasing. But out here what you see, out here beryllium, boron, carbon, nitrogen, oxygen. Okay. So, beryllium and boron, that means it is increasing, that means beryllium, boron is greater than beryllium. Okay. Sure. And nitrogen is less than, the oxygen is greater than nitrogen. But out here it will be reverse. That is the exception. See what is beryllium and boron. See what is beryllium electron configuration 1s2 2s2. That is the in this orbital, pill orbital 2s, in boron 1s2 2s2 2p1, that is one orbital there. Clear? In case of what you see, this is the 2s orbital, this is stable orbital, and there is 2s and 2p, 1s, 2s and 2p orbital. In the 2p orbital is not so strong, s orbital is very strong than p orbital. So, only one electron from the p orbital, it is easy to remove. So, in that case the IP of B, IP of B is less than the IP of beryllium. That is, beryllium is greater than boron. That is the exception. Next come nitrogen, oxygen. It should be greater than this. Come to the electron configuration. Nitrogen 1:2:2p3, 1:2:2p4. Same thing. There is p orbital, 3 half pill orbitals. There is partial, there is electron. In this case, number of electron is greater. I know electron is negative charge, and 2 more electrons, they are also negative repulsions, and also that is, this is the negative electron repulsion is more, and also this is half pill, it is stable. So in this case, this will be lesser and this will be greater. In this case, nitrogen will be, IP of nitrogen will be greater than the IP of oxygen, which is the reverse. This is also exception. Very important, very important. This will come in the competitive exams. In case of magnesium, aluminum, phosphorus, sulfur, okay, I come to the downwards. That is the according to the group wise, or the group wise. See, aluminum, gallium, what will be there? It will be downwards, decreases. That means aluminum greater than gallium. But what we will see now, give the examples, gallium and aluminum. See out here. In case also magnesium, sulfur, same explanation you have to give, but down the group I am giving the explanations. Aluminum and gallium. Aluminum 13 और gallium कितना होगा 31. Okay, not required. Aluminum 13 not required. That means इसमें लास्ट सेल में कितना है 3s2. okay, 3p1 ये है. इसमें 3d10 गैलियम का 3d10 4s2 clear, 4s2 and 4p1. So what you see out here? Next, what you see out here? This is the explanation I have to give. The 3d10 it is fulfilled, and in this case the shielding effect is less. Shielding effect is less. Aluminum and gallium. The explanation. So what you see down the group, it is decreasing. That is, aluminum it will be greater and gallium will be lesser. But out where this shielding effect is less. So IP in this case will be greater. Okay. So here gallium will be greater than aluminum, which is the against the rule according to the period. Clear? Then one is topic is their valency and also diagonal relationship. Okay. Valency also, you know, the valency is the combining capacity of element. Valency is the combining capacity of the element. You all know from the class 8, 9, 10 capacity of the element. You also from the very beginning know it. It is the actually expressed in terms of the number of hydrogen atoms, number of oxygen atoms, number of chlorine atoms that combine with one atoms of the elements. The number of, in the set of combining of the electronic configurations, the number of valence electron determines the valency of the atom. Number of valence electron determines the valency of that atom. For representative elements, you have to know the valency. There is no fixed valency. Number of valence electron, the representative elements के क्षेत्र क्या होगा? The number of the valence electron or the 8 minus number of valence electron is the valency of the atom. Clear? For the representative elements, I also told you representative elements, transition elements, inner transition elements, representative elements. I have told you S block, D block, F block, all are discussed. And in this case, the number of valence electron is the valency or 8 minus number of the valence electron, whatever you can say. In case of 7, 8 minus 7, 1. In case of 2, there is the 2. There in case of 1, this is 1. Okay. In case of 7, 8 minus 7, 1. You can minus subtract 8 minus the valence electron or the valence electron is the okay. And the periodic wise, remember that in case of transition element, there will the valence will be the variable valency. Transition elements valence will be variable. The period wise you have left to right and up to down group wise, the valence increases from left to right. Valence increases left to right. Clear? but with respect to fourth, very important, fourth, that is a hydrogen and chlorine, first and this, it increases first from 1 to 4, then first 1 to 4 it increases, then decreases from 4 to oxygen. Okay, first increase, then decrease. lithium, beryllium, boron, carbon, नाइट्रोजन, ऑक्सीजन, फ्लोरीन, लिथियम हाइड्राइड में लिथियम, बेरिलियम हाइड्राइड में बोरोन हाइड्राइड, कार्बन CH4 मीथेन, NH3 सब हाइड्राइड जब फॉर्म किया गया विद रेस्पेक्ट टू हाइड्रोजन, विद रेस्पेक्ट टू क्लोरीन, लिथियम क्लोराइड, बेरिलियम क्लोराइड, इसमें क्या होगा जब 1 2 3 ऐसे होगा. ग्रुप वाइज वैलेंसी आर सेम एज ग्रुप नंबर जो होगा, जिस ग्रुप में वही है उसका वैलेंसी. ग्रुप नंबर वैलेंसी आर सेम एज ग्रुप नंबर. सर ग्रुप 1 उसका वैलेंसी 1, ग्रुप 2 उसका ग्रुप वैलेंसी 2, ग्रुप 3 वैलेंसी 3, ऐसे होगा. क्लियर. सो नेक्स्ट द एनोमलस ऑफ द period or groups, that is the diagonal relationship of the elements. It is very important. One may come diagonal relationship. See out here, after the another trends, it is the anomalous property. Diagonal relationship means such the anomalous property. Okay. So elements of the second period resembles with the elements of the third period. Elements of second period resembles the elements of the third period elements. कैसे? And diagonally. If you see lithium, beryllium, boron, carbon, nitrogen, oxygen, okay, fluorine, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Okay. In this way you can add. So if you relate this lithium to magnesium, beryllium to aluminium, boron to silicon, okay, carbon to phosphorus, ऐसे diagonal relations. What do you see? That there is a resemblance of this, that is the diagonal relationship. Diagonal relationship is known as the diagonal relation. Why? What do you know? According to left to right, it will increase, and down the group the property is decreased. So it is increase then decrease. So ultimate value will be same, constant. This is increase, and from this to this, like from here to here, that means this and this. This is increase, then again decrease. So ultimate value is same. This is the diagonal relationship. What is see? Suppose how to find out the, suppose the questions come, what is the diagonal relationship aluminium to barium? barium के साथ किसका diagonal relationship है? सिलिकॉन के साथ किसका है? सिलिकॉन का पीछे किसका साथ है? Directly we cannot say. So there is a short tips I am giving. You have to add and subtract 9 with the element. Suppose you are given lithium, तो lithium का diagonal relationship कौन element है? Which elements है? That is resemblance. lithium का atomic number कितना? 3. तो lithium plus 9 is 3 plus 9, that is 12. 12 किसका? magnesium. No, lithium, magnesium. Okay. बोरोन प्लस 9, बोरोन का कितना? 5. तो बोरोन प्लस 9, 5 प्लस 9, 14. 14 कितना? सिलिकॉन. द बोरोन का सिलिकॉन. इफ यू कम फ्रॉम सिलिकॉन टू बोरोन, you have to subtract 9. So silicon minus 9, 14 minus 9, 5. That is the boron. This is the diagonal relationship. Okay, clear? Okay, that is the last thing I have discussed. So I hope this chapters is crystal clear to you. If any doubts, if any queries, please ask me and comment me in my comment box, that is given in the description box. Okay, link is given there. So you don't forget to comment, don't forget to ask anything. Okay.